Hello again. Today we're going to continue to look at the one-sided limits. I've had a lot of folks with kind of some questions about the pictures, and then today we're going to take the next step and start looking at some equations related to the same topic. All right, so what we're going to be looking at are, again, our one-sided limits and how they relate to a basic two-sided limit. All right, so first off, over here on the picture, we've got our a equals 1. So that's what we're going to be using. So essentially what we're looking at is we're focusing on what's happening at that spot right there. What's happening when the x value is 1, or in this case, a equals 1. All right, so first off, we're looking at the limit from the right-hand side. And again, that's what this little plus sign there means. It means we're coming at that point, in this case 1, but we're doing it from the right. So that means we're coming along from this direction towards the 1, and we want to know what happens essentially the moment before I get to 1. Where am I? Well, right before I get to 1, I am down here at -2. All right. Next one, I want to look at the same limit, but this time I want to be coming from the left, and that's what that little arrow or that little negative sign there means. It means coming at a, again in this case 1, but from the left-hand side. So I'm coming in from this side, and I don't know if you can see it very clearly, but there's an open circle there, which doesn't mean anything really right now. I want to know what happens right before I get to that open circle. The very moment before I get there, that's what a limit is. It's not what happens at that moment. It's what happens the moment before. Where's the next step? So right before I get to that open circle, I'm almost at +2. That's where my next step would be. But again, I'd be stepping into an open circle, which means I'm not really there. So the actual value at 1 isn't 2, it's -2. But again, as you're approaching it from the left, you're nowhere near -2. You are right near +2. Now, third part, just the plane limit. For the plane limit to exist, the left-hand and right-hand limits must match. Since these limits do not match, that means that this does not exist. It doesn't match. It isn't the same from the left as it is from the right. If it were the same answer, then the limit would be that number. If those are both -2s, then the limit for x approaching a would also be -2. All right, so again, it doesn't matter what's happening at the dot. It's about what's happening as you get closer and closer and closer to it. All right, that's what a limit is. It doesn't mean what's happening at that spot. It means what's happening as we approach. All right, now here's what's different today. We're going to be looking at it without a graph. We're going to be looking at it based on the actual function values. All right, but we're still doing the same thing. We're still asked to find the same exact information. In this particular case, we're asked to find what's happening when a is -1. There must be some sort of hole there. And the fact that I'm getting -1s listed here is a good sign. I'd be willing to bet that there's another hole or another open spot or another potentially weird thing happening at -4 or at 3. And those are the numbers that are listed here. All right, so first off, I would like to find out what's happening as I approach -1 from the right. So I have to kind of think about a number line. So think about this as a big number line. And our number line looks like it goes from -4 all the way up to 3. Again, those are the numbers that are listed there. So I'm just going to kind of sketch in a generic number line. It's not going to be perfect, but close enough. All right, now I'm going to try to color code this a little bit so we can kind of see what's happening. All right, so at first, over here, in between -4 and 1, the red equation is happening. You got an or equal to at -1 and not 1 here. So that's where the red equation is happening, over here. Now, the middle one, that's happening everything here between the -1 and all the way up to 3. That's where the green information is located. And then everything greater than 3, oops, sorry, I forgot that the green one was also an or equal to here. And then everything greater than 3, that's this blue thing here, going to the right. All right, so we are trying to find out, first off, what's happening as we are approaching -1 from the right. That's this first one. We approach -1 from the right. So again, we are coming along this way. Here's our little guy, He's coming from the right, and he's walking this way. I don't know what's happening as we approach that. Well, we're walking along the green line as we approach -1 from the right. So I want the green answer when a equals -1. So I'm going to plug in a equals -1 into that equation. I can't tell, that looks like it's a 2. Again, we're using the green one. That's the middle one. So I'm plugging my number, -1, into the green one right now. I want to know what's happening as it approaches that particular spot. Well, that would be 4 minus -1 squared. Well, -1 squared is 1. So 4 minus 1, I'm getting 3. All right. Now, we're going to take a look at the next one. Now, what's happening as we are approaching -1 from the left? So as I over here, I'm walking, I'm approaching -1 from the left-hand side. Well, that looks like I'm standing on the red line, so that means I need to use that top equation, and I'll be plugging in -1. So that'd be -1 squared plus -1 plus 3, and that would equal 3 also. Now, if those are different answers, then the regular limit, the dual-sided limit, the third one here, would be undefined, or no, does not exist. But since those two answers match, then this is also the same answer. Again, for a two-sided limit to work, its one-sided limits must have the same answer. For a two-sided limit to not work, then that would mean that the one-sided limits have different answers. So if I'd have got different answers there, then they would have said that the limit does not exist on that third line. But because the two answers matched, that means that the limit does exist, and it is that number. All right, so you have a little bit of both today. A few graphing, some review, and then a few of these types where they're written in equation form. So you know how to get a hold of me if you need help. I am going to be on the Zoom today, even though it's a Wednesday. So get me if you need anything. Good luck.